So for the last part of our trigonometry unit, we're going to be looking at solving some more complex problems. So these are going to involve more than one triangle where we might be missing a piece of information. So we're going to be looking at scenarios with more than one triangle. And we're missing some of the information. So often we have to solve kind of like a roundabout parts before we can find what we're actually looking for. So for example, in my first question, we're looking at solving for side AC. So if I was to highlight AC, this is side AC, the whole thing. Now the problem with that is that if I draw a triangle ABC, this is not. So we've got this 52 and 31 would be 83 degrees. Note that this triangle is not a right triangle. That means that none of the rules that we've been talking about will work to help us solve for side AC. But what we can do, because we do know that this can be split up into two smaller triangles, is we can split it up, and that gives us two smaller triangles. So we'll have triangle AC CDB, and we'll have triangle ADB. And each of those triangles, so I have CDB, which is 52 degrees, and it is a right triangle. And I also have triangle ADB, still 14, right? This side length doesn't change. I'm just splitting it up so I can see the two triangles. 31 degrees. Now, I can't find ADC all at once, but if we say this is one and this is another, the length that I'm looking for is going to be the first length plus the second length. So as long as I can find those two lengths, I can still find the missing side. So if I go back to my triangle drawings here, what I'm looking for are these two missing spots. Now, because these are right triangles, I can use my trig ratios. So here, I can use the fact that O is opposite and 14 is adjacent, and I can use that SOHCAHTOA to find the missing side. So I'm using tan of the angle is opposite, which is y, over adjacent, which is 14. Now, this part is exactly the same as the trig we've been doing so far. We just need to get y by itself by getting rid of that denominator. And we're going to go 14 times tan 52. Which is, get my calculator. Of 14 times tan 52. Ooh. Oh, this is a backwards calculator. And that gave me 17.9. So now I can write that in as side y. So when I solved side y, I got 17.9 centimeters. And I can do the same thing for x. So from angle B, which I know, x is opposite, and once again 14 is adjacent. So again, I can use tan. Now this time I'm using a different angle because the triangle that I'm looking at is different. So x is opposite and 14 is adjacent. So same thing, we're going to need to multiply. And go back to your calculator. And this is where make sure you know how your calculator works, because you notice I stumbled a little bit there because my calculator was functioning backwards. And I'm not used to this one. 8.4. Which makes sense because it's a little bit smaller there. Now what I'm looking for is this entire length. So to find my final answer, I'm going to need to go 17.9 plus 8.4. $26.3. So that's one example of a problem where we have two triangles that we have to use to find the full length. That's an example of addition problem, which is basically just where two side lengths get added. To find the unknown. Subtraction problems are very similar. Now, once again, this time we're looking for side BC. So if we draw the triangle that BC is in, once again, this is not a right triangle. Which, if we don't have a right triangle, means no SOHCAHTOA. Right? We can't use SOHCAHTOA, and we can't use Pythagoras. So that means that we're going to have trouble with what we know right now to solve this triangle. So I'm going to need to look at the bigger scenario here. So what we're going to do is, instead of just looking at CB, we're going to look at this bigger ACD triangle that I have. So I actually do have two right triangles here. I have triangle, so we have the big triangle, which that's not very straight, CAD. Now, because I'm looking at this whole big triangle, we're going to add these two angles together. So in total, that's a 33-degree angle. And AD is 12 millimeters. So with this triangle, we would be finding this whole side length, right? Because we're finding AC there. We also have this smaller triangle. Because angle A is a right triangle, means I'm going to be able to use those rules that we talked about. Now this time, because we're only looking at the smaller triangle, sorry, this should have been a 53. We're only going to be using that 32-degree angle. But AD is still 12 millimeters. So that's going to help me find this side. So once again, if we call this X and we call this Y, so we're calling this Y and we're calling this X, what I'm looking for, side BC, I'm going to need to find X and I'm going to need to find Y. CDB is going to be the difference, right? The leftover after we take those away. So let's start by finding X. So just like before, if I know an angle and I know a side, I can find the missing side. So I'm going to start with my opposite and my adjacent. So that's, once again, if we write out our SOHCAHTOA, opposite and adjacent, we'll use tan. And we're always doing tan of an angle, right? Unless we're looking for the angle. It's going to be X over 12. So we're going to go to my calculator. (12 times tan 53). going to be 15.9. Okay, so that means that side x that I found there, the big long one, is 15.99. And then we can do the same thing with the smaller triangle. So once again, opposite and adjacent means that I'm going to use tan. Now this time, because we're working on that smaller triangle, I'm only using the angle that's a part of that triangle. And we need to get that y by itself, so we're going to multiply by that 12. And we're going to go to my calculator. 12 times tan 32. Remember, you need to know how your calculator works. This one's a backwards calculator, so it's a bit wonky. 7.5. So if I want to find out just the top section here, I need to go the big side minus the short side. So 15.99, 92, wait. Oops, just 19. Sorry, 15.9 minus 7.5, 8.4. Okay, so there's no new trigonometry happening here. It just might be a little bit different in how you're going to get to your final answer. You might have to take a couple of steps to get there. And that's what this last one really exemplifies. So here, I want to find what it's asking me for is side AB. Now the nice thing here is that if I draw out triangle ABC, I do have a right triangle. Which is very exciting because that means that I can use trigonometry on this triangle. Now the tough part is that I don't have any side lengths. So even though I do have a right triangle here, I still can't solve it because it's missing a piece of information. So for me to be able to solve this, I need to find one of the other two sides. Now luckily, I have this second triangle here, which includes this same side. They have a shared side. So it doesn't matter which triangle I'm calculating with there. So I can use triangle ABC, which I know has 17 millimeters, to find this in-between length. And once I find that, I can then calculate on the triangle I want. So, because this is once again a right triangle, we can use our trig. So SOHCAHTOA means I'm going to use cosine. Now this time I have a variable on the bottom, so to get rid of that, first we need to multiply both sides by that y. And now we need to divide to get the y by itself. So this is solving that we've done before. So in my calculator, we're going to go 17 divided by 31 cos 19.8. And that makes sense because it needs to be longer than the side. So we just found that this is 19.8 millimeters. Which means that we can translate that, because if it's 19.8 on one side, it's also going to be 19.8 on this side. And that means that in my triangle, we now have a side. So once I've done that stepping stone, I've found one missing side, now I can solve my triangle. So from ABC, we have opposite, and we want the hypotenuse because it's across from that right triangle. Careful with that one because the triangle is shaped funny. So O and H For my SOHCAHTOA, it's going to be sine. And we're using the angle that I'm referencing. Opposite is 19.8. Hypotenuse is x. Now this is a similar solve in that we have to get rid of that variable. Before we can get it by itself. And we talked about before, if you want to turn sine into a decimal, you can. I like to hold on to it. 19.8 divided by sine 68. 21.4. Now it's also important to note here that most of the examples that we've done have been solving for sides. It could also ask you to solve for angles, but the same idea still applies. It'll either be you need to add angles together, you need to subtract, or you're going to need to find missing pieces before you can solve for those angles. So here's an example of an angle 1, right? So same idea. So it wants angle MNO, which is this whole big angle. Now triangle MNO is not a right triangle. Which means we can't directly use SOHCAHTOA to find that missing angle. But similar to the first one, if we split it up into two triangles, one with angle N here and the other with angle N here, we could add those together to find the total angle. So I need to work with those two different triangles, one being MNP and the other being ONP. So because they share that 18 side, it applies to both triangles, but they have a little bit of a different one here. So what I'm looking for in both cases is these missing angles, right? We want to find x and we want to find y. Because if we add those together, angle MNO is going to be x plus y. So for x, we're looking at opposite and adjacent. And because this is a right triangle, I can use my trig ratios. Now this time I don't know the angle, so instead of putting a number there, we're using x, right? We have to have all of those spots filled in. So to get an angle, we're going to use that inverse tan function in the calculators. So we'll have 11 divided by 18, and we're going to use the inverse tan. So I got 31 degrees. So that means the top half here is 31 degrees. And down here from y, 18 is going to be my adjacent, and 22 is my hypotenuse. So A and H on my SOHCAHTOA is going to be cosine. Once again, I don't know the angle, so I'm using a variable. And so to find the angle, we're going to use the inverse. And we're going to go to our calculator. 18 divided by 22. And inverse cos, 35 degrees. So what is that angle in total? 31 plus 35, 66 degrees. So once again, it's just another addition problem, with the difference being we're adding angles instead of sides.